Welcome to the R video tutorial on non-parametric tests for center or mean in R. Now what we're going to do here is look at situations where your standard tests don't work for some reason, usually non-normality or a lot of the assumptions can't be validated, maybe non-constant variance or whatever. So these are alternative tests. Now when you use these tests, just know that they have lower power than their parametric counterparts. All right, so I've got some data that I've thrown out onto the repository. It's called complaints.csv. The link to the repository is below. You can go out, grab the data, and then we're going to read it in and look at it real quick. So we're going to run this real quick. Notice it pops it up. I'm going to pop it up over here. So you might want to go back and pause it if you didn't get all the code. Notice I have different stores, and these are the number of complaints across a 9-week period that are sent to the headquarters of the chain, and I just have a small portion here. So notice that people like to complain a lot, and maybe a complaint isn't necessarily like a complaint, but it's registered through the complaint department. Maybe somebody didn't get a refund quick enough or something, but it does get sent back. All right, so one of the things we could probably do here before we ever try to do anything is just look at the scale of these things. So like this one goes up to 153. So store one goes up to 153. But, you know, some of these others don't go nearly as high. So in this one, store 3, 62 is the highest. So there's probably some non-constant variance here as well. And we're not going to test that because you can do that in a previous video. But just know that the assumptions aren't met. All right, so let's give this a go. First thing we want to do is look at the data. And we're going to look at them one at a time just so we can get a sense of what's going on. So the first thing I'm going to do is a histogram, and I'm going to do from my data comp 1. I'm going to look at store 1, and I want to color it, let's say, blue. That way I can look at the picture here. Let's run this. Notice that this is not mound shaped. This is highly skewed to the right. So that's one big flag that we should be worried about. The other problem is there's only 6 observations here. So we should take that for a problem as well. We have low sample size and things are definitely not normally distributed. So what we can do is try to use a non-parametric test on this. And suppose we want to test to see if there's more than 5 complaints per week, or let's say 25 complaints per week. So let's test to see if there are more than 25 complaints per week on store 1. Okay, so what we're going to use is what's called the Wilcoxon Test. And it's also known as the Mann-Whitney test if there's more than one variable. But we're just going to run with this right now. So I'm going to do comp 1, $store 1. And if we run this, we're going to have a problem. So what we should do real quick, so you get used to this, because the reason I'm going to make you do this is because sometimes you want to look at the help and sometimes you don't. But if you only have one variable, let's look at the test and see what pops out. So over here we have this. And notice we're going to have to define a mu. Now our mu in this case is 25. So let's just pop that in here right now. So, I have a problem. There we go. Mu is equal to 25. Don't just run it blank. A lot of people run it blank. If you look here at the help, this is why I'm purposely looking at the help. Mu is 0. It will give you a significant value, even though what you're trying to test is not significant. All right. So we're not doing anything paired. We're not worried about exact right now. We're not really want a confidence interval. So we're going to do a 2-sided test here. Let's see what this produces. So it gives us the Wilcoxon signed rank test. Notice we have a p-value of 0.3594. So we would not reject it in this case. We would say that they are the mean can't be determined to be different than 25 based off of our data. Even though there's so much spread in it, we still can't say the mean is not 25, which is pretty amazing. That also means that this thing has really low power, but don't worry about that right now. So suppose we want to compare 2 stores. So let's put a little space in here. And we want to compare 2 stores. We're going to compare store 1 to store 2. Test to see if the mean, or I'm not going to put mean, it's actually the median complaints for store 1 is different. I'll put this over here. Than store 2. So again, we're going to use the same thing. Wilcoxon Test. We're going to put in the 2 things now. So comp1 $ store, and then the second store, comp1 $ store. And if you're trying to do this, remember when we're comparing 2 groups, we're actually looking at their difference. So we're looking for the difference to be 0. So just keep that in mind, that we are looking for the difference here. So we don't need to set mu. That's why I purposely brought up the help there so that you can check this to make sure that you do the correct thing. So let's give this one a go. Okay, and it says a warning, cannot compute exact p-value with ties. That's fine. It's just telling you that it's using an approximation. Okay, and that's fine. And notice we get a p-value here that has 0.7238. Okay, so this still is not significantly different because we only have 6 observations or 9 observations. It doesn't really make sense that we would have a lot of power to find anything. But you should also keep this in mind whenever you're doing your tests or you're running anything, really. Just be aware that often you cannot tell the difference between many of these things. All right, so let's see if we can test across all of them at once, like an ANOVA test, to see if any of the complaints or any of the stores have different complaints. Okay, now here we'll use a different test. This is going to be the Kruskal-Wallis Test. Okay, now if you're not familiar, well, obviously you're not familiar with the Kruskal-Wallis Test, but here we're interested in like an ANOVA type test. We have more than one center, more than one grouping that we're interested in. So what we can do is actually put in the data that we're interested in, and here it's just the whole thing because there's no other information in this data set. If we come back and look at it, there are no row identifiers that says this row is this or that row is that, belongs to males, females, northwest, northeast, anything like that. The only information we have are the stores and how many complaints they had each week. So if I just dump this in, you can see that this will produce the Kruskal-Wallis test, and it's just going to test each column separately. There's also a way to do this for groupings. If you have groupings, you can put those in as well. And you can also use a formula just like you did in ANOVA. So let's say you did ANOVA, you found something that you thought might be significant. You did the Bartlett's test, which is in a previous video, and it rejected. So you can just copy the formula directly out of it, and it should work. All right, let's see what this does. Okay, so this ran the Kruskal-Wallis test, and it's a rank sum test as well. And notice here, this is not significant. So 0.4099. All right, so this has been our video tutorial on non-parametric techniques that are used for centers. If you have any questions, please ask or go to the next video.